Hello everyone, welcome to the channel. So this is going to be a fairly in-depth video of us installing the underground hydroelectric service into our property where our house will be in the future. So just to give you a sort of a rundown of what we're dealing with here, we've got about approximately a 1,450 foot run in from the road to where the transformer vault is located near where the house is going to be located in the future. So pretty long run, and that run of a power comes in from the road at a high voltage. I think it's around 7,200 volts into the transformer, and then it gets converted to usable power by your house, that type of thing. So 120, 240. So basically, in our area, in these digging conditions here, ideally you'd want to get down 30 inches for this type of cable, and you can direct bury it as long as the backfill material isn't too sharp or rocky, angular, that type of thing. So here we were rarely able to get down to the full 30 inches. So what the Electrical Standards Authority in our area made us do is get down to the rock, and then as you can see here, we are breaking rock for, in our case, it was pretty much the entire length of the trench. So we broke rock for 27 hours. This is sped up dramatically from what the actual conditions were like. It's very slow going. But basically we had to break 8 inches into the rock, and then they wanted us to put the high voltage cable in DB2 PVC conduit, which we'll see later in the video, laid into that broken out rock trench, and then we're going to cover the whole thing with concrete to protect it from the top. So basically the rock protects it from the sides and bottom, and then the concrete protects it from anything from the top that might damage the cable and the PVC conduit. So this is us just cleaning it out here, cleaning out the trench in preparation to lay the cable and conduit in. And so because it's such a long run, we couldn't actually lay the conduit and pull the cable. It overstresses the cable with this distance, so we had to figure out another way, which you'll see. Okay guys, so I've got 1,300 feet of pipe laid out here. So this is 10 100-foot sections not glued together yet, and then there's another 300 feet up there. So right now I'm just going to start gluing these together, and then we'll next step will probably be rolling out the cable and getting ready to slip these pipes over. Okay, so basically, like I said there, what I'm doing here is I'm just priming all the ends and then putting some PVC solvent cement on these and gluing them all together. So we figured 100-foot sections at a time, would be fine to slip over. We didn't want to create too much of a friction situation when we're pulling this over the cable, so we figured 100 feet would work. In hindsight, we probably could have gone 200 feet at a time, but like I said, it worked for us. We only had to do it about 13 or 14 times. We made one more 100-foot section after this video was made. So there they are all laid out in the field, ready to be pulled over the cable. Okay, so I just want to show you guys this initial setup here. This is the first 100-foot pull of wire. So this will, where the ATV is where the hydro pole will be. So I've got 45 feet of wire set up there, and the electric company, Hydro One, right to that yellow thing there, will have 45 feet of wire to go up the pole. And then the first section there to the second yellow tab will be in sand. And then this is where the concrete DB2 trench starts. So basically we're going to be pulling that all the way to where the pole is going to be. And then I've slipped 100 feet of DB2 conduit onto this. And then I'm going to have my dad following me with the skid steer and the reel there. Because basically the first 100 feet is between a bunch of trees and things like that where we can't really get the machinery in, so it'll be easier to put this in beforehand. And then after that we're going to run the wire down the driveway, and then we're just going to slip 100-foot lengths at a time over the cable. Just want to show you quick the reel setup. So we're just going to pick the reel up with this chain. Then I got this 3-inch axle or 2-inch axle where I just welded a plate on the end there, and then on this end I feed it through. And then I've just got this other plate with 2 screws in it. You tighten those bolts down and it holds onto there, then the reel can spin fairly freely. So as you can see, we're just cruising down the driveway here, heading out to where the pole is at the road. So we got that section installed, that first 100 feet, right to where the pole is going to go. And now I've just got sort of a half hitch string on the cable there holding it while my dad backs up, and we're going to uncoil this whole reel. It's a 500 meter spool. It's the length it's the shortest length I believe it comes in. And we're just uncoiling this right out the driveway, right out into the field, and we're just coming to an end here soon. There's the last little bit coming off, so we're going to take it right off of there, and then we're going to get a string on this. Okay, so I'm just feeding the string through the 100-foot section of conduit right now. So easiest way we found, just a plastic bag there onto some pull string, and then I've got this Milwaukee battery-powered leaf blower, and it's just pushing the string, pushing the bag, pulling the string through, and then you can see it's already out at the end of that 100-foot section. It takes like a couple seconds, way better than like a fish tape or any other method. So then we have the ATV here, just a bar on the front to sort of keep the conduit beside you instead of pulling it on the hitch so the driver can see what's going on, because sometimes the cable would bind up at the front there. And just slipping essentially this PVC over that cable, and we're heading right to that first 100 section that comes in from the pole. And then once we get there, we glue it together, and then we keep doing that, and we did that 14 times for the full 1400 feet. Worked really smooth. We didn't lubricate this. We did it on a fairly dry day. This is how I'm holding the end of the cable. So I've got a stake driven in the ground, that 100-foot piece of fish tape, and that just holds the cable while you slip the conduit over. Because I mean, it does try to sort of pull the cable with you, but there's not much tension on this string. It's hardly anything. You can actually hold it just by hand, but it just keeps everything nice and tight, and so that there's no sort of bunching up of the cable in front of the conduit. And so right here, we've already pulled, I believe, 12 lengths of the 100-foot conduit over, and my biggest worry was that it would sort of rub on the cable. But you'll see, I'll just pick it up here, and I mean, after 1,200 feet of pulling conduit over, there's hardly any damage to the outside of this cable. I mean, this cable is very durable. It's meant to be buried directly into the ground if your conditions allow you to. But so very durable, and nothing wrong with doing it this way from our experience. I mean, it's the cable's good as new. So I think I would attribute that to doing it on a dry day. You don't want a super wet day where it's picking up grit on the cable and then dragging it through the tube. You obviously want to make sure your conduit is clean on the inside, which if you get it from the factory, it's usually perfectly clean on the inside. There's no issues there. And this method works very well because, like I said, you can't pull 500 meters or whatever it is of cable. It's just this cable can't take that sort of pulling tension. So the big, the hydro companies, electric companies, they would pull this, but they would do it in stages. And for us, that would mean having to put some kind of vault halfway down the line, which we didn't want to do. So this is the vault, they call it, that the transformer sits on. So the transformer is like a green box you see in subdivisions. So basically this gets buried in the ground. All these holes are for your primary wire to come in. You can pick whichever one. Well, actually for the primary wire, you're only allowed to come in the bottom row of holes, any one of the bottom ones. And for your service wires, they can go out any of the holes. So depending on the location of your buildings and things, you got to kind of pick which one's the best option. So I'm just taking this out of the truck right now. I've got my aircraft cable there that I'm using to make these lifting straps you see here. Because the actual way to lift these concrete precast things is with special lifting lugs that you can buy, but they're quite expensive, and I almost never use them because we don't do this very often. So Like I said, what I did here is I took these pieces of aircraft cable, put loops on the end, and then I used a zip tie, as you'll see here in a second, to sort of hold them onto these galvanized lugs until the lifting pressure holds them on. So hopefully that makes sense. It's just a quicker, cheaper, easier way to get off. I just had to do two lifts here out of the truck and then into where it's going to sit forever. And you can see there, it worked pretty well. Okay, so there's the vault installed. There's no video on that, but it's basically just sitting on flat limestone there, and we just leveled it up with some shims, and then when we poured the concrete over top of the conduit coming from the road, we put a little bit of concrete all around it. I think there's a little bit of video of us doing that actually after this. But basically the primary wire comes in the bottom there, and then the dark gray conduit and the light gray conduit are both going to be secondary service. The light gray one is going to this this panel mount that I'm making right now, and it's going to an outdoor service panel. Again, I'm going to talk more about this later once it's all installed, but basically I'm just making the mount right now. So it's two 4x4s, and I'm using pressure treated fence boards on the top there, and then I just screw the panel on, and there's an LB fitting on the top and then another LB fitting at the back that takes the wire up and over and down. You can't go out the bottom of this panel. It's got a weatherproof rating, so you pretty much have to go in one spot, and that happens to be the top. So here I'm just putting some rebar into the limestone there, and then I'm sort of making a little concrete form around this. This will all be buried, keep in mind, so it doesn't have to be perfect. So rocks around, and then we end up filling this with concrete. This is for our ground wire, so it's just a 1/2 inch piece of conduit. Ground is going to go down and into the ground. Okay, so here's some footage of us actually pouring the concrete. So this is what I did the whole way from the road to the vault here, and this is how we covered it with concrete. I'm in communication with the cement truck driver with those headsets we have on, and basically he's just got the chute in free flow mode, and I'm able to tell him, shoot up, shoot down, increase the flow, decrease the flow, increase your speed, that type of thing. So it made it a lot easier than, waving hands, and because both my hands, as you can see, are busy with the chute. There's quite a bit of concrete coming down. So I think for the 1,400 foot trench, we used 21 meters of concrete, cubic meters of concrete, I believe. 21 or 24, I can't remember. But anyway, so we've got about 3 to 4 inches of concrete over top of the conduit, and then, like I said earlier, the rock protects the sides and the bottom. And then right at the end here, you can see that the conduit goes over top sort of an edge or shelf of rock, and I really wanted to make sure that was protected, so we really dumped in the concrete at the end here. And this is just a DeWalt pencil vibrator, cordless obviously, and I'm just giving it a little bit of vibration here just to make sure that concrete flows really nice around and underneath the conduit in this area, because it's basically just totally exposed if it didn't have this concrete around it. So I'm just making sure it's all consolidated properly. And then so my dad's just throwing like I said earlier, a little bit of concrete around this vault here, around the shims that we put in to level it up. And then I'm just sort of going by, right, like you see here with the vibrator, and vibrating it so that the concrete sort of flows underneath, and then it'll hold it in place forever after we backfill. So there's the marking tape that is required by code. So if someone ever were to try to dig this up, theoretically you would hit the tape first. So that goes the whole length of the trench. And so this is pretty good backfill here. I mean, a little bit rocky, but really at the end of the day, this thing is totally protected. So if you got a couple, pieces of rock, things like that falling into this trench, it's not a huge concern, because, it's not going to break through that 3-4 inches of concrete. Okay, so this is the day that everything got inspected by the ESA. So this was the final inspection. before they clear it for Hydro 1 to come in and connect everything. So the only thing we have left to do here is backfill up to about 4 inches from the top of that concrete vault. And we'll backfill around the panel posts there and around that central metering 6x6 that I will explain in a second here. So basically the power comes in from the road, like I had already mentioned, and it goes into one of the lower holes of the vault there. And then the DB2 conduit protrudes in about 6 to 8 inches. And then I foamed around the wire there to keep the rodents out and protect the wire a little bit. I left 15 feet. I believe you only need to leave 10 feet of wire in this vault, but we had lots of it, so I left 15 just to be safe. So the 7200 or 7400 volts, can't remember which it is, comes in from the road there and gets transformed into, you know, normal electricity that you would use in your home, so 120 or 240 volts, and then it gets sent through these wires that I'm pointing at here into just a residential or commercial panel. So you've got your red and your black there, which are each carrying 120 volts, and then your white is your neutral. And in this case, it just goes through that light gray pipe up into our outdoor panel. Other things in this vault to mention are the grounding wires there. So we've got 2 grounding wires and these are strategically placed. These aren't just random. So one goes out and it goes all the way around the vault, exactly 1 meter out. And there's 4 grounding plates all the way around here. So they're just standard galvanized grounding plates like you might use in your home. And then the other grounding wire comes out and goes just to the 1 grounding plate. And that essentially creates a grounding grid all the way around this vault if ever anything were to ever short out inside the vault. So in our case, we're using ground plates because we were allowed to by code, because we're on solid bedrock, and it's pretty much, like, it's not impossible, but it's very difficult to put in ground rods, which would be the ideal situation. So ground rods are like 10 to 12 feet long, and they have to go into the ground, which again would be very difficult in our case. So we're using these ground plates instead, and as long as they're covered with the specified amount of cover, so native ground, they work just as well as ground rods. Okay, so as I mentioned before, this is a CM, central metering service. So in our particular case, we can have up to 4 electrical panels coming out of this vault, going to different places on the property, and they all get measured by that 1 gray meter there on the 6x6 wood post. So basically what we have here is, like, so right now I have 2 of them, or potentially 2 of them connected. So in that dark gray DB2 right there I'm pointing at, it stops just short of that wood board. And during the construction of the house, or whenever we like, we just dig to that wood board and then run our wire through and connect it to the transformer. We'd call Hydro for that. They lift the transformer off, connect it. And that just keeps us from having to dig really close to the vault once we've backfilled everything, just to avoid hitting wires. There's a lot of wires coming into this, so you'd want to stay far away from it. So anything that on the property, any panel that comes out of that is measured by that 1 meter there, and you get 1 bill at the end of the month. The other light gray conduit that I have there is actually going to be hooked up as soon as Hydro comes and puts in the transformer, so we have power to the property right away. This is another grounding plate for it. So this is in addition to the 4 grounding plates you saw earlier, and that grounding plate is connected to the wires that go around the vault. And just like a normal panel in your house, the grounding wire goes up in and is actually bonded to the panel. So by that I mean the neutral and the ground are bonded together because it's a main service entrance. So that green wire just indicates that that is the ground wire. So any power that gets used by this panel, for example, and any other panel will get measured by that meter in the back there with the little blue round cover currently. So it just makes it nice, whereas a normal service for a typical home, it would come in from the road, probably already transformed onto your roof or underground through a meter and then into the panel in your house. So the only difference with this is you're just measuring power going to up to 4 different places. So we'll backfill this temporary, or I guess it's permanent, service panel, outdoor service panel, and then we'll slope everything away. There's the sand we're going to put around those 2 conduits there and around the base of the transformer just to protect things a little bit further. And then we'll just use native ground to backfill to within 4 inches of the vault there. So I think I got a little bit of video of that now. Okay, so it's been about a month since the backfill, and everything's connected now. So there's just a quick view of the new pole and the 2 wires coming across the road from the other new pole. And there's your connection up at the top there with a breaker, and then the power heads down underground to the transformer. So Hydro One came in and put the transformer in the other day. So there it is there. And there's our meter. So that is measuring everything that goes through this green box that's transformed. And then we have a temporary panel here. And right now it's just running these 2 plugs. You can see the little green light there on the GFCI. And then that black tech cable right here is going to like a sub panel over in a shelter logic that I have in the back there. So that's pretty much it, guys. If you got any questions about this whole thing, just let me know.